efficient as we take these tests. Chapter 9.
I realize how I got 8 wrong.
You guys did corrections together on this. I literally gave you guys time as a group, so I can give your classmates their tests back.
Wait, I remember I didn't do all of the corrections. Did I?
Oh no, I did correct this.
Did you?
I think. I'm not sure.
Would you like to compare with what?
Did we master our corrections?
I didn't grade them yet because I didn't have Jake's. I do batch grading, so I grade everything at the same time. Unless I stuck your test in a different part of my binder.
I feel like I probably messed up the corrections.
So, I have not graded the revisions yet. But Connor, if you want yours back to compare with Jake, you guys did the revisions together.
What revision? What did you get for this one? Wait, actually, that one.
I think on the one you guys forgot to point it downward.
8 for...
8.
Wait, for what?
That's what.
Wait, what are you on?
Yeah, no, that's what I said.
8? Wait,
What? How did?
8B.
Where did you get that?
Because it's maybe a 13.
Wait a second. What did I...
But how did you? Why did you flip this sign?
Okay, I don't
Hey,
get...
could we maybe run through the lesson really quickly and then you guys can look at those and make sure that they're good to turn back in and be mastered?
Oh, I know what I got. Okay.
All right, so real quick, we're gonna burn through this lesson super fast, like the fuse on a black cat. I don't know, because I said burn through just as like get through, like. But we often, when we're camping and things like that, you're kind of blocking Jake being able to see the board. Just by the way, so when we look at a three-dimensional prism and we're talking about volume, that's pretty much easier than surface area. What's the efficient way to do surface area on a prism, especially a rectangular prism?
Surface area is well, there are 2 different ways to do it. You can either do 2 times one of the sides, like in parentheses, one of the sides plus another one of the sides plus the third side, the third pair of sides. Or you can just do 2 times all of those put together.
Do we get this formula on the state test? Or?
We can look at your formula page again, but it does not give you much.
It doesn't?
Wait, we have a formula?
Actually, let's look at those. That's not until after spring break. We'll talk about the test a bit more specifically all together. So yeah, if I call this length, width, and height, we just want to make sure that we use each of them twice. So length gets used there and there, height gets used here and here, and width gets used here and here. So that works for a three-dimensional rectangular prism, and then volume just length times width times height. So here, though, does not use the same formula. What will every prism do the same if we're talking about surface area? What will every prism have the same? Not like the same numerically, but if we're talking about the work that we need to do to find surface area of a triangular prism.
It's kind of the same thing again, except we do not multiply by 2 this time.
What does get multiplied by 2?
The top and bottom.
So we call that the big base, or the big B, which stands for the base, which is a tiny bit misleading because it's not always the bottom, right? Then now we call it big B because then alternatively we sometimes use little b. So if I call these sides A, B, and C conveniently lining up with if we had a Pythagorean theorem, and we know that C is actually 5, we would then for surface area also add A times B, B times C, and A times C. Again, using each of them twice. No, this is a mistake. I'm just trying to see if you guys are paying attention.
I don't get the shape of this prism, but
everything I wrote in green is wrong.
It's 9 times C and 9 times B and 9.
So what should I actually be? A, B, and C should act H. So every prism has a height. Right? So our height, quote unquote, is the distance between the bases. It's not always how tall is it, how it looks in the picture. So I can rotate this any way. My favorite line from the movie Ender's Game is when, I forget what they're doing, but they're like, it's the first competition they've had in space, and Ender essentially says, in space there is no up or down, right? There is no, like, you have to just, everything can turn and be manipulated. So the height is if you identify the bases based off the name of the shape, triangular prism, the distance between them will always be your height. So what we actually need to do is A times H, B times H,
I feel like there's a better way to say it.
and C times H.
Because they're kind of just repeating the times H every time. So I feel like it'd be better to put to say like H times all like sides.
So you're saying H times A plus B plus C?
Is that how math works?
So you're saying factor out the H from each of these and instead do H times A plus B plus C?
Yeah, I was more trying to like extrapolate to any kind of prism.
What you're doing, well, so we're gonna do that. What you're doing is saying this triangle was the base, this triangle was also the base, but these three sides around are one big rectangle. So if we can find the perimeter of the base shape, this is really
That's so cool.
just the perimeter of the base. So for any three-dimensional prism, it's 2 times the area of the base plus the height times the perimeter.
That's not that hard.
Oh, and volume for any prism.
Base times height.
What?
It's base times height, right? Well, yeah, it's base times height.
Big B.
Well, yeah.
We specifically say big B because big B is the area of the base. Okay, so big B when we reference it, and if there are formulas on your state test, big B is always used as area of the base. So volume for a prism is always big B times H. So here, go ahead and try this out. Find the volume and the surface area of this regular hexagonal prism. And if you want a reference to look at, here you go.
Can we use the board?
Yeah, absolutely. Get this table out of here.
Okay. Shapes. Wait, is this the regular shapes?
Yes, so grab the hex. Ooh, wait, hex.
Oh, yep.
There we go.
Okay, so we got, well, that doesn't look regular to me, but I guess it is.
It's because at the right, it's at perspective. So the hexagon you're seeing at like angled.
Make the isosceles triangle so that we can find the area of this hexagon. Okay. So we got,
I would make sure that we're all doing this on our own.
this is,
So Jake, I hope you're diving into calculating stuff and not just like playing Snake. You're good. I trust you guys. I'm just saying.
How would I even get snake on my calculator?
Dude, there's 100%
Yeah, you can.
Snake for TI-84. That was one of the games I had on my calculator 20 years ago. And I'm not joking. At this point, it was 20 years ago. You just download it off the internet.
you just,
Plug-
oh,
plug
is
your-
it 36?
I'm telling you things I probably shouldn't tell you.
I'm
I
stupid.
mean, if you just go search up TI games, you can download them. You just plug your
Yeah,
cable
I
in.
think Clark got 2048 on his calculator.
All right, so in a hexagon,
So
what are
this
those?
is 4 radical 3, right? Because it's 2 radical 3 times, and that's times 6, so it's actually
So wait, what sort of triangles do we have there?
30, 60, 90.
30, 60, 90 in
24
hexagon.
radical 3 is this, I think.
24.
I got 290.98.
20%.
That doesn't, wait, you got 290?
Well, how
The
do you
whole
get
area
4
of the
square
entire
root 3?
prism.
Isn't it 2 square root?
So,
Because it's
hold on,
2,
back up.
and
You're-
then
Your 24 radical 3, what is that?
that's 2 times this 2 radical 3, right? Because that's 4 radical 3s. And then multiply, oh, I need to half it.
No.
No, I do.
No, you don't.
No, you don't.
Oh, no, I don't, because that's half, yeah.
So what is the 24 radical 3?
It's the area of the,
So So it's the
The big B?
big B. So label that your big B. Like throw a big B equals in front of it.
Big B.
Sweet. Now continue.
Okay. Big B. And then we can multiply that by 7 to get the area.
The volume.
Yeah. What's that times 7? Jake?
168 radical 3.
Thank you.
And that's the nicer way to write the number and the more exact way. In decimal form, Jake.
Yeah, it's 290.98465.
So rounded,
290.98.
well, or 291 if we went around to the nearest whole number. Right, because 0.98, that's so close. I mean,
It's like 0.985.
yeah, it's so close to 291, I would just round it. Because even if you round, think about it, if you round to the hundredths place, the 5 rounds the 8 up to a 9, and then we'd have 0.99. I would just round to the 291.
Okay.
All right, sweet.
48 radical 3.
No, wait, where?
Because that's times 2. And then,
Okay, so you're doing
Plus.
that is your 2 times the big B.
what's 24 times 7? Which is 168,
So
right?
24 is our perimeter of the hexagon, right? 6 times 4, so perimeter all the way around the hexagon. You could just write out 24 times 7 and then we can get it. Or Jake, do you want to check what 24 times 7 is?
168, right?
Yeah, it's 168.
Yeah, because right here we did
So
that.
then we could either leave that in kind of like a binomial form, right? 168 plus 48 radical 3.
Wait, 48.
Because there's 2 of these.
Oh.
This is the
okay.
surface area.
24 rad 3 doubled. Sorry, I'm trying to go fast, but please slow me down if we need to slow down.
Great handwriting, I know.
Beautiful. Just beautiful. All right, one quick thing and then an interesting principle. Not Mr. Flynn.
Yeah, Minister Flynn isn't very interesting.
All right, so in a circle, how would that change?
It's the same. Except
Yeah.
we're using pi a lot more.
Okay, so we'd be using pi a lot more. So big B here is really going to be like pi times radius squared.
It's fine. Well,
So 25 pi. How does finding the
it's 10 pi is the circumference.
so we would first find circumference for our distance around the circle, and that's 10 pi, and then that,
So 80 pi plus.
yeah, so we're going to have 80 pi plus 50 pi from 2 of the bases.
So 100. Wait, well, yeah. So it's 130 pi. That's a lot of pi. And then the volume is just big B times 8, which is
200?
Yeah.
So volume would be 200 pi, whatever the units cubed.
Huge. Where's the other one?
All right, any questions on applying this to a cylinder? Big B times height still applies. 2 of the big bases, perimeter times the height. Make it a big old rectangle. But still, even in a cylinder, yeah, technically we think it is, right? Because a prism is any shape that copies the bases at the top and bottom. Even if I take this apart, this becomes a big rectangle, right? If I lay it out, the rounded edge can become a straight edge. Cool. All right, Cavalier's principle from the really 1600s, if we're talking about when he was making his principles. I doubt he was doing it when he was 2 years old.
1 year old.
So, this relates to calculus. We're going to look at this really quickly and then move on to the next lesson. So suppose we have a stack of 25 pennies. And like I sometimes do to the Jenga tower, I decide to shove the stack a little bit. And it's still standing, but it is, instead of standing straight, now standing like this.
Huh.
Does the volume of the stack of pennies change because...
No, but that volume would change.
What do you mean? What do you mean, no but that?
With the stack of pennies, it has a bunch of little ridges to it. And so this, you're missing out on all the ridges. Oh, no, because it kind of cuts through. Oh, never mind then.
So wait, what did you just conclude?
Like, because with the pennies, it kind of cuts the ridges on one side and then moves them
kind of like we do with, what's those shapes where if I cut the triangle off the one side?
Parallelogram?
Yeah, parallelograms. Kind of like parallelogram, which actually it really looks like a parallelogram just in 3 dimensions. The volume would not change, right? So Cavaliere's principle was a principle that stated a slanted cylinder is going to behave the same as a straight up cylinder as long as we use the right measurements, and that's why we need to drop the altitude height and not use the slant height. Right? The slant height would give us a misleadingly larger volume than what we actually need. Make sense? Same with when we're setting up the surface area and that rectangle around the surface area, we still need to use the actual height. All right, well, which then we often call the altitude. This is technically called an oblique cylinder. All right, we know all of this, and you guys know this, and you like wanted to yell at me for not believing it because you guys already knew it. All right, so similar solids, and I bet you can kind of jump to what I'm gonna say. Anyone want to try to take the words out of my mouth?
As you continue your study of three-dimensional solids
I mean, continue.
does anyone explain how the volume of a solid changes as the solid is enlarged proportionally?
So, since you know what we're doing, we're enlarging solids and comparing volumes. What would happen if I double the size of a solid? What happens to its volume?
It quadruples.
No, 8,
No,
I think.
no.
Because it has 3
It's
dimensions,
8 times.
right? Yeah.
How do we say that?
It goes to
It's fun. I think the word is fun.
I don't know.
8 octuples?
8 octuples. So, how could we formalize this that the volume of the scaled shape, so let's say we're using a scale factor of 3 instead of a scale factor of 2.
It's
What
the
is
power of
then?
3.
Yeah, so it is
Scale factor
the
of power.
the new volume
Volume nuevo.
is your scale factor cubed what? Well, but there's something else I need to put into the new volume is scale factor cubed,
Times the old.
yeah, times the original volume.
1
Makes sense. Questions? We don't really need to do this. This is how we discover that, but you guys are smarter than the average bear. So,
Solid with blocks.
so if this is a 1 by 1 by 3, right, what would we call the volume?
3.
So the original volume is 3. If we scale factor it by 2, what's the new volume going to become?
Then it's, yeah.
No.
12.
8 times
No,
3, 24.
it's not.
No, it's 24.
I think we've got 2 answers to get us to the right answer. Let yourself have time to think. Guys, especially on the state test. I know, like, seriously, you're all smarter than me. I'm not trying to build you up because whatever. You're all smarter than me. But the problem with that is you guys know you're smart. Except you second guess yourself a lot. Give yourself time to think. Do not gut reaction. Oh, this question's easy. Click, move on. Think about them. We just got 2 answers before we got to the right answer because we just didn't think. Right? 2 cubed would become 8. 3 times 8 would be 24 for the new volume.
Working with scale factors in more dimensions gets progressively more confusing.
Maurice.
Maurice.
Why would you count that?
You don't count your popcorn kernels? You don't there's 5 in this and 5. Neither do I. All right, so the number of kernels of popcorn that filled his small tub is 320. Okay, have you ever thought about, though, how a small compares to a medium or a medium compares to a large? And, like, how many smalls are in...
McDonald's, they put the
See? People think about
The
this.
more you buy,
I didn't know it was on TikTok,
the
but...
bigger you buy, the cheaper it normally is. Like, not like.
But now, this is the funny thing, and there's all sorts of research about this. Now, consumer science is messing with people because they know that's what people think. So they know people grab the bigger container, and if you don't actually analyze the unit price comparison, sometimes the bigger container costs more. So I have this great picture from Kroger, and it's probably in my math pictures folder on here, where there was aluminum foil, and there was a 75-foot roll and a 200-foot roll. And I could get 3 of the 75-foot rolls for cheaper than the 200-foot roll. Same exact foil.
What if you need 200 foots of cohesive aluminum
Yeah.
foil?
Yes, Connor. That's we're rolling out to. Okay. So in that case, unless you're going to weld the foil together, which I don't think can happen, you're right. You'll buy the 200-foot roll.
Yeah, it might melt. It might weld together, but it wouldn't do it nicely.
So if let's actually solve this problem, because otherwise we could just speculate lots of things for a while.
About aluminum foil.
The small tub. By the way, whoever had the box that said tin cans, are they actually collecting aluminum cans, or what are they?
Wait.
Who's?
There's a can of.
There's a box in the family room that says tin cans, and it's from one of the 8th grade impact projects, I think. Are they actually collecting like pop cans? Okay. Sorry, you're the only 8th graders I really like get to interact with much.
It's like actual cans or canned food or what?
Right, I don't know if they mean soup cans or like pop cans, because I could bring in some pop cans. Similar to the small tub, but it's 1.5 times as tall. Now wait.
1.5 cube.
Is it though?
Is it one?
As
Well, they're not.
Oh no, it's
Wait.
not. Wait.
What do you mean it's not 1.5 times the salt? Oh, but it's also more thicker.
More
He decides the next time he will get a medium tub that is similar to the small tub,
Oh.
but 1.5 times as
No,
tall.
yeah, it is 1.5.
Yeah.
So is everything scaled by 1.5?
If it's similar, then why wouldn't it be? That's the question you gotta ask yourself.
1.5 to the third is 3.375 times 320.
Let me double check because I don't like how this question's written.
1,080.
Yeah. So, sorry, my brain was mixing up that the circles would be congruent, but yeah, if it's similar, so if it's not just 1.5 times as tall, yeah, I mean, even
Well,
congruent
1.5
circles are
is-
similar.
1.5 is like edge length and stuff, and then so that means that you would keep that's the scale factor, so you would cube it.
Yeah, so the circle would have to be 1.5 times as big as well.
That's chunky.
So yeah, 1,080 kernels.
That's a way better.
So yeah, if you compare 320 to 1080, that's like way different.
How
Okay,
much
this
more
is where
does it cost?
similar circles, cans, paint buckets, things like that, they get much larger, much faster.
Because they have all those sizes.
And if you can believe it,
All those different.
that's the 2 lessons I needed us to
Great,
get
we have 6
Wait, the second lesson was
So-
like 2 seconds.
That's why I merged them. So I would love it if we could get our homework done so we're not working from behind,
That too.
especially because there's less AO time this week.
But not behind.
All right, or chapter 9 revisions. Make sure the test is all good and revised, and then I need those turned back in